This is Eric Grimes and Ryan Oliva's demonstration of an axial flux permanent magnet generator to prove Faraday's law of induction. For stator construction, we designed and then rapid prototyped small coil spools. This allowed us to easily wrap them with magnet wire. It also left the center of the spool open so we could later add some ferromagnetic material to increase our flux linkage. Each row held 10 turns, and each spool had 5 rows, for a total of 50 turns. Here are all the parts of the system laid out before assembly begins. The rotor is made up of a steel backplate with 6 machine pockets. Each pocket contains a neodymium iron-boron magnet that is bonded into place. The magnets are oriented in a north-south-north orientation, and the rotor backplate is attached to a spindle. Here, the finished coil spools are attached to the stator backplate. The stator backplate is also a rapid prototype part and attached with 2 screws from the bottom. This shows the optional insertion of the ferromagnetic core. The alternating magnet poles on the rotor will create a sinusoidal AC voltage when spun above the stator. For measurement purposes, we wired the stator in a 3-phase star pattern through 2 full bridge rectifiers to convert the voltage from AC to DC. Faraday's law of induction states that time-varying flux linkage induces voltage in conductors. To prove this and test different parameters, we mounted the stator base in the vise and the rotor in a spindle of a vertical milling machine. Flux linkage can be described as the number of turns in the coil times the magnetic flux. To vary the magnetic flux, we can simply change the gap distance between the rotor and stator with this setup. We also know that the induced voltage equals the change in flux linkage over the change in time, or speed of the rotor. To test this parameter, we can increase or decrease the speed of the spindle. The output voltage of the generator was measured at varying rotor gap distances as well as varying speeds for the stock stator. Then, the steel cores were added to the stator and the measurements were taken again. The data shows what Faraday's law of induction predicted: the increase in speed, as well as the increase in flux linkage due to reduced gap sizes, and especially steel cores in the stator, increase the overall output of the generator. Due to the relatively low number of turns in our coils, as well as some manufacturing issues that kept us from achieving very small gap distances, the output of our generator was very low. This was enhanced even more by the voltage drop due to the full bridge rectifying circuit. Here's the AC component produced by a single coil as seen by a multimeter and its waveform on the oscilloscope.